Hello, my name is Sean.
And I'm Hunter. And today we are going to be testing Newton's second law by dropping different sized and masked balls into a thing of flour. So the materials we use today is a little glass container. We use all-purpose enriched flour, bleached flour. We're using Lipton Recipe Secrets, and it is onion mix. And then we have 3 different balls. This one's kind of just a normal bouncy ball. This one's a bigger bouncy ball. And then this one's a plastic hollow baseball. So what we are gonna do is I'm gonna drop the different balls into there, and we're gonna test and measure the impacts that it makes. Start with this one, and then we're gonna do the plastic one, and then we're gonna go with this one. And then Sean is gonna measure all 3, and then I'm gonna talk over. So basically, the smaller size, decent size mask, I believe is gonna go deeper than the one with the bigger size but less mass. But the one that is gonna go the deepest is gonna be the one with the most mass and in the middle size. But the one with the most size and the least mass is going to be able to create the biggest crater, but not as deep as the other 2. Yeah.
Well, you were way off.
Okay.
So the rubber ball was 1.5 centimeters, the plastic ball was 2.5 centimeters, and the big rubber ball that we did was 2 centimeters.
Oh, wow. So I was off. Alright. So Sean, explain the science between that.
Okay, so what should have happened was that the reason why there were different sizes, or there was different size craters, is because since we dropped them from a fixed height of about 1 foot, every time each of them fell, the impact that was needed to stop it was based off of the density of each ball. So pretty much the heavier the ball, the more net force was required to stop it. And for some reason, our experiment failed and we sucked at it. And yeah.
Alright, so then the second part of the experiment is we're going to add a barrier on top. So basically the barrier is meant to resist the impact. So instead of making the more deeper impact, it's going to be able to kind of stop it a little bit more. It's kind of like brakes in a way of a car. So we're just going to gently pour this on top. And I have 2 bags just in case one of them isn't enough. Alright, Sean, if you could pour the other bag. And it smells very good. Alright, well, even though I was wrong with the last one, I believe it's the same thing. This one's going to be the deepest one, this one's going to be the second deepest, this one's going to be the third deepest. So here we go, we're doing the same order. Alright, and then we're going to move them. Yeah, I think I was right with that one. Yeah, from the looks of the eye, I feel like I was correct on that one. See, that one's definitely the deepest of the 3.
Alrighty then. So the rubber ball, the regular size rubber ball, that was 2 centimeters on the first try, and it was 2.5 centimeters on the second try. The plastic ball dropped dramatically. It went from 2.5 centimeters to 0.25 centimeters, and the rubber ball went from 1.5 centimeters to 0.4 centimeters. So this all happened because since we added another layer, there was more of a net force that was required to go through, but since we kept dropping them at the same height, since that other layer was there, it didn't go as deep. And that's the science behind it.
That's it, folks.